Okay, it's been a while since I've done some videos here, trying to get back on track. So I'm going to be working here. Let's see, what do I want to start with? I'm going to start with chapter 8 because that's where we are right now. So 8.1, and we're going to start out here. Chapter 8, Section 1, get my board marked here. Right about here. All right, so 8.1 and 13 through 25 odd. Is that right? 13 through 25 odd. $35 through $45 odd. $49 and $51. All right, let's start out with number 13. Which of the following inequalities describe where sine inverse of sine of x is equal to x? All right, so really this is just trying to figure out if you can determine what the domain is here. So all we have is a restriction here. Remember that when we are doing this arc sine, we know that the sine function, sine x is going to go here, arc sine x is going to go back. So originally the sine function has domain of all real numbers, but its range here is -1 to 1. In order for this to work, we have to make a cut that's going to send this back. And basically every number here needs to come from one place, so we cut this off between -pi/2 and pi/2. And so the appropriate restrictions that we would have to make on x in order for this to be true is that we would have to restrict the domain of sine, what we're plugging into sine, between here and here. So that means option D would be correct there. Option D. All right, next question, number 15. Find arc sine of 0. So when you say arc sine of 0, what you're asking is on the unit circle, where is your y-coordinate 0? And we're using the y-coordinate because the y-coordinate is given to us by sine. So we're using arc sine, which means we're looking at the y-coordinate. So where is the y-coordinate 0 here? That's going to be here at this point, right, 1, 0, and then also at this point, -1, 0. However, even though it looks like we have two different points where this happens, because of the restriction on arc sine, we cannot be in these two quadrants. We can only be between pi/2 and -pi/2. So this is the only solution, and the angle is actually 0. 0 degrees or 0 radians. So that's it for number 15. Number 17, what's arc sine of -1? Same story. We are going to be looking for where the y-coordinate is -1 on this unit circle. We're not allowed to look over here. And the only place that happens is down here. Now, what is that angle? It is not 3pi/2. You cannot go all the way around like this. You can only go backwards. So this is an angle of -pi/2. Okay? Number 19, arctangent of 0. So this is asking us, because we're looking at arctangent, we must only look again in these two quadrants between pi over 2, or between negative pi over 2 and pi over 2. We can only be in here. And this is asking, since it's arctangent, it's saying where is the y-coordinate divided by the x-coordinate equal to 0? Well, that can only happen if the y-coordinate is 0. So where is the y-coordinate 0 here? At this point right here, which corresponds to 0 degrees or 0 radians. So the answer is 0. For 21, what is arcsine of root 2 over 2? Again, we're looking at the y-coordinate. We're trying to figure out where's the y-coordinate root 2 over 2. And because it's arcsine, we're still cutting off just this left half. And that's going to happen right here because this is the point root 2 over 2, root 2 over 2. So you can see the y-coordinate there is root 2 over 2. The angle is pi over 4. So we have pi over 4. Oops. Pi over 4. Ah! Pi over 4. 23. We doing 23? Yeah. Arctangent of root 3. So again, we're cutting off the left side. We're trying to figure out where's our y-coordinate divided by our x-coordinate equal to root 3. Well, it's not going to be here. This is 1, 0. This is 0, 1. This is 0, negative 1. So it's not going to be at any of these corners because if we take the ratio y divided by x, we don't get root 3. It's not going to be at the 45 degrees in negative 45 degrees because here the x and y coordinates are the same, so the ratio would be 1. Here the coordinates are the same but differ by a sign, so you would get negative 1 here, so it's not those. We could also look at the fact that this is a positive number, which means that the ratio has to be either, they either both need to be positive or both negative. And the only place that's going to happen is up here in the first quadrant. Okay, both the x and y coordinates are positive. Here, the x coordinate is positive, but the y coordinate is negative, so we couldn't get a positive number if we tried to take a ratio down here. So we can kind of eliminate this down here, which really only leaves 2 of the common angles. It's this one, 1/2 root 3 over 2, and then this one right here, which is root 3 over 2 and 1/2. So we're going to take the y coordinate and divide it by the x. If we try this one and we take the y and divide by the x, that's the same as 1/2 times 2 over root 3. The 2's cancel, you get 1 over root 3. That's close. That's not what we want though. So it's not this one. So let's try that one. So we do the y coordinate root 3 over 2 over 1/2. But this is really root 3 over 2 times 2 over 1. 2's cancel, you get root 3. It's exactly what we wanted. So this angle here is pi over 3. So our answer is pi over 3. All right. Oh, finally, arc cosine of negative root 3 over 2. Arc cosine of negative root 3 over 2. Yes. So this is asking us to look at the x-coordinate this time, because it's an arc cosine. Where on the unit circle is the x-coordinate negative root 3 over 2? However, because it's arc cosine, we are only allowed to look in the first and second quadrants. Our angle that we get, our answer must be between 0 and pi. So where is our x-coordinate negative root 3 over 2? Well, that's right there, because that's negative root 3 over 2, negative, and then positive 1/2 for the y-coordinate. So that angle is actually 5 pi over 6. So 5 pi over 6. All right, next one. Use a calculator. All right, so just get on your calculator, type in the arcsine for number 35 and arc cosine. You should get For 35, you should get negative 0.12. For 37, you should get 1.08. So I'm not going to do those. You just use your calculator. Make sure you're in radian mode. If you're in degree mode, you're going to get the answer. It'll be correct, but it'll be in degrees, not radians. So the book gave the answers in radians. All right. Number 39. What is arc cosine of 4 pi over 5? Arc cosine of 4 pi over 5. All right, so this is the cancellation property. This will be equal to 4 pi over 5, so long as this lies between 0 and pi. Now, the reason why is because the restriction we have to make on the cosine function in order to define the cosine inverse function is from 0 to pi. And that goes back to that picture. We're going to go, we know cosine will go from -1. We'll go, cosine x is bounded between -1 and 1. But when we want to go backwards with an arc cosine, then we have to restrict this over here. So this, pi, 0 to pi. 0 to pi. So this cancellation property will hold so long as this is between 0 and pi, and that is between 0 and pi, because 4/5 is less than 1. So this is less than 1 pi, which is just pi. All right, let's look at arctangent of tangent. By the way, that was number 39. Number 41, arctangent of tangent of -3 pi over 8. Okay, for this one, I'm actually going to start with the picture. Our tangent function spits out things between -infinity and infinity. That's what it spits out. But in order to make the inverse be defined and be a function, we had to restrict the domain of tangent. And if you go back and look in the notes, we restricted it between -pi/2 and pi/2, not including the endpoints. So this should just spit out -3 pi/8 so long as this lives in here. So does it? Well, 3/8 is smaller than 4/8. And 4/8 is a half, which is this guy right here. So the way to look at it is like, if you're looking at a number line, here's -pi/2, here's pi/2, here's 0. This right here is somewhere right in here. Therefore, it lies within that interval, so the answer to this should just be -3 pi/8. So cancellation property again. So far, we haven't run into any problems. All right, now number 43, arc sine of sine. Arc sine of 9 pi over 8. All right. This is going to be a little tricky. All right. This will hold true. This will just spit out 9 pi over 8, so long as 9 pi over 8 was inside our restriction. Our restriction for sine in order to define the arc sine is this. So we have to have an angle between here and here. We do not have that, okay? 9 pi over 8 is bigger than pi/2. So, and also, that's not a common angle. So I'm going to try and do this with a picture. Try and figure out where we are. All right. Imagine that the 9's not here and I just have pi over 8. That means I'm going to take pi, which is 180 degrees, I'm going to cut it into 8 equal pieces, which means we're going to have, oops. Let me see, one more. Okay, so that's 1, 2, 3, 4, 5, 6, 7. All right, let me see. 1, 2, 3, 4, 5. Oh, whoa, I went way too many lines there. I need 4 sections in each one, so I need 3 lines. Okay, so imagine that this is pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. Okay, and then we have 9 pi over 8 right here. Okay, so sine of 9 pi over 8 is the y-coordinate right here. All right, the y-coordinate is the distance from here to here. Okay, imagine like a little right triangle. That distance right here is this piece. Okay, we don't know what it is, all right? I'm not going to get my calculator out. Now, because this 9 pi over 8 does not live in this interval, remember we have to cut off this side. What we can say is that this distance is equivalent to coming over here straight across. It would be equivalent to the y-coordinate right here. But what is this angle? What is the angle that gets you to this point? Well, you can't go all the way around. Remember, we're cut off over here. So we could rotate counterclockwise here. And if we rotate counterclockwise here, that one little section is the same as one of these. So that should be an angle of negative pi over 8. So this should equal negative pi over 8, because taking sine of this gives you this y-coordinate, right? And then whatever that y-coordinate is, we're saying, hey, where on the unit circle, right? Arc sine of that says, where on the unit circle is the y-coordinate this much? But you can only look over here. So it's going to correspond to the angle of negative pi over 8. Hope that makes sense. I know I did not do one like that in class. Let's do 45. (45) is arctangent of tangent of 4 pi over 5. All right, we're dealing with an arctangent here. When we're dealing with arctangent, we know that what we can plug into the tangent has to be between negative pi over 2 and pi over 2. So on the unit circle, we're cutting off this, and tangent of 4 pi over 5. Let's try and figure out what 4 pi over 5 where it would be. This might be kind of hard. We got to cut pi into 5 pieces. So let's see if this is pi all the way around. Let me do it this way. If this is pi, that top half of the circle, if I want to cut it into 5 equal pieces, I need 4 lines. So from here, I don't know, 1, 2, 3, 4. So that would be pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, and then 5 pi over 5 would be pi. So we're looking right here, okay? Now I'll put it over here so you can see it. So we're trying to find tangent of that angle. Now tangent of this angle is going to be, here's the x-coordinate, here's the y-coordinate. It's going to be this y divided by this x. Now keep in mind that if we're over here, the x-coordinate's negative, the y-coordinate's positive. So look at this as being, this x is a negative number, and this y is a positive number. So when I take the ratio, I should get a negative number. Now, if we're trying to figure out what angle, right, like this ratio, okay, the ratio of y over x at this angle, then where else on the unit circle would you get that same ratio? Where would you have the same x and y coordinates that would give you the same ratio that this would? And you have to be looking over here. So would this one work? Just directly across? Well, it wouldn't, because even though the value, the distance of x, those distances are the same, this would be a positive x value, and the y value would also be positive. So both of these would be positive, and when you took the ratio, you would get positive. That's not what we want. Instead, this angle right here, right there, this would give you an x and a y. See, these were both positive numbers. Here, this distance, right, that distance should be equal to this distance, except it's going to be positive instead of negative. And then this distance and this distance are the same, but this one should be negative instead of positive, like over here. So if I took the ratio of y over x here, it should be equivalent to the ratio of the y over x here. And the angle that corresponds to this, remember these were pi over 5s, would be us going back by pi over 5, so negative pi over 5. Those are good problems. I should have done something like that in class. All right, let's look at number 49. Make sure that's where I am. No, yeah, 49. It's easy when they're common angles, but when they're not common angles, it's not so easy. 49. Arctangent of tangent of pi over 2. All right, right away, tangent of pi over 2 is not defined. Okay, you cannot plug pi over 2 into tangent. That's where you have a vertical asymptote. So this whole thing is undefined. All right, 51, sine of, arc sine of 1/4. This will be 1/4. The reason why is because if you look at what you're allowed to plug into arc sine, it has to be between -1 and 1. This is between -1 and 1, therefore it should just spit it back out. So you really no work there. What else do we have here? That was it? Okay.